Hi, this video is going to be looking at resultant forces. Objects have many forces of different strengths acting on them in a variety of different directions. These forces acting on an object can be replaced by a single force that has the same effect on the motion as all the forces acting together. This force is known as the resultant force, and it tells us information about the motion of the object. We can have a few different scenarios, such as the object being stationary or moving, and the resultant force being 0 and not 0. We're going to look at a stationary object first. If the resultant force of this stationary object is 0, it will result in the object remaining stationary. If the resultant force of our stationary object isn't 0, the object will accelerate in the direction of the resultant force. So let's suppose the resultant force on this ball was acting in a rightwards direction. This ball is stationary, and as the resultant force is not 0 and it's acting in a rightwards direction, this ball will move in a rightwards direction. Now we're going to change our example slightly, and we're going to assume that our object is now moving. If the resultant force of an object that is moving is 0, the object will continue at the same speed and in the same direction as it was travelling before. If the resultant force of a moving object is not 0, the object will accelerate in the direction of the resultant force. So if we have a resultant force of an object that is non-zero, the velocity of our object will change. We have 5 different cases of how the velocity can change. The first case is starting, and this is when we have a stationary object which has a non-zero resulting force. The object will accelerate in the direction of the resulting force. The remaining 4 cases occur when the object in question is moving. Cases 2 and 4, which are stopping and slowing down or decelerating, occur when the resultant force is in the opposite direction of the direction of travel for the object. So it would occur if our object is travelling towards the right and the resultant force is in a leftwards direction. Speeding up or accelerating occurs when the resultant force is in the same direction of the travel of the object. So if the object was travelling rightwards, the resultant force would also be rightwards. This would result in the object's speed increasing. The final case is 5, and this is changing direction. This is similar to 2 and 4, and this occurs when the resultant force is acting in the opposite direction to the direction of travel. So if our object was travelling in rightwards, the resultant force would be leftwards. This would result in our object first decelerating, then stopping momentarily, and then starting in a leftwards direction. And this results in our object changing direction. For the examination, you are only required to work out the resultant force acting on a straight line. So let's have an example. Let's use the example of a moving push bike. The rider of the push bike pedals, and this results in a driving force of 300 newtons. We're going to assume that our biker is travelling in a rightwards direction. The biker has another force acting on him, and this is wind resistance. This force is acting in the opposite direction, and we're going to say that it has a magnitude of 200 newtons. So as this force is acting on the biker in the opposite direction, we're going to put this in a leftwards direction. So we have a leftward arrow with 200 newtons on it. From this information, we can work out the resultant force on the biker. We do this by working out all the forces in one direction. In our example, we're going to work out the forces in the rightwards direction. There is a positive force of 300 newtons from the biker pedaling. There is also a force acting in the opposite direction, and this is air resistance. Air resistance in our example has a magnitude of 200 newtons, and it's acting in a leftwards direction. If we put this in a rightwards direction, it has a force of minus 200 newtons. So in order to work out the resultant force, we add all of the forces up in a rightwards direction. So we do 300 newtons plus minus 200 newtons, which is 300 newtons minus 200 newtons, and this gives us a value of 100 newtons. Therefore, the resultant force is 100 newtons, and the bike is accelerating towards the right. So let's have another example. The example is going to be similar to the one that we've just gone through, but we're just going to change some of the values. Let's suppose now that our biker is travelling at a speed of 5 meters per second. He is biking with a force of 300 newtons, but the wind has increased to 400 newtons. What happens to the speed that our rider is travelling at? So our first course of action is to draw a diagram and show the forces that are acting on this object. The biker here is travelling in a rightwards direction. Our biker is pedalling with a force of 300 newtons, and this is acting in the same way that the biker is travelling. There is also wind resistance on the biker, and this is 400 newtons, and this is acting in the opposite direction to the direction that the biker is travelling. So this is acting leftwards. In order to work out the resultant force, we need to work out all of the forces in one direction. Let's calculate all the forces in a rightwards direction. As our biker is travelling to the right, the 300 newtons is going to be positive. The wind resistance is acting in the opposite direction to the direction of travel, and therefore we have minus 400 newtons acting on the biker. We then sum all of our forces, so we do 300 newtons plus minus 400 newtons, and this gives us minus 100 newtons. A negative value means that the biker is going to be accelerating in a leftwards direction. As the biker is currently travelling in a rightwards direction, a negative number means that our biker is going to be decelerating. This brings us on to equal and opposite forces. Whenever two objects interact, they exert equal and opposite forces on one another. Let's suppose that we have a cup that has been placed on a desk. Gravity forces the cup downwards. Let's say that this force is 5 newtons. This figure comes from the weight of the cup and gravity, and we're going to look at this in more detail later on in this course. The table pushes upwards with the same force, which is 5 newtons. This is known as a reaction force and is why the object is in balance. If there was no reaction force, the cup would accelerate downwards due to gravity. We can work out the resultant force, and we do this by adding all of the forces in one direction. Let's take the downwards direction. There is 5 newtons pushing downwards due to gravity, and 5 newtons pushing upwards because of the reaction force from the table. The 5 newtons pushing downwards is going to be positive because that's in the direction of travel that we're taking, which is downwards, and the 5 newtons pushing upwards is going to be negative because that's in the opposite direction to the direction of travel that we're taking. We then sum these two forces together, so we get 5 newtons plus minus 5 newtons, which gives us 0 newtons. The resultant force therefore works out as 0 newtons, and as our object is already stationary, it means that the object is going to stay in the same position. This brings us to the end of this video. For more content, quizzes and past papers, go on to www.elevise.co.uk.